this practice, we will use clustering again to analyze some dataset, and this dataset is coming from again some store, and this store has recorded for different people how often they have gone to the store, so how many times, how many transactions they have done in 2011, 2012, 13 and 14, even 15, so for 5 years. And they have also recorded what was the date of the first transaction, or what is the date of the latest transaction, and then how much they have spent along these years. So for instance, this person went to the store in 2011. He went to the store twice, and he spent $153 in these 2 times that he went to the store. And then in the next year he spent more, and he went 7 times, and yeah, so and you have this kind of information for almost 7,000 people. And after removing the missing data, we don't have so many, so we have only 4,000 people that are attending for the going to the store for 5 years. And yeah, this is a list of the variables we have, so how much money they have spent in each one of the years, and then how many times they have gone over these years. And we will remove some of the data that we will not use for the clustering. So the customer ID it is a string, and even if it is a number, it doesn't make sense to cluster according to a number that is arbitrary. And then we will remove the dates. Okay, so we start by describing the data. So we saw computing minimum, maximum, means, standard deviations, these kind of things. So we see that standard deviation, so the mean is more or less constant in these years, and it is smaller in 2011 and even smaller in 2015. So probably this means that the study and the data collection started in the middle of 2011 and finished in the middle of 2015. So that is why in the 3 years that are within this period, we have more or less constant mean, but then at the beginning and at the end, because the year is not complete, we have lower means, and then obviously minimum standard deviations and minimum everything. Okay, so then we will make a scatter plot, and because we have two different variables, so we have on one side the number of transactions, and on the other side the amount spent in those transactions, the total amount spent in those transactions. We will plot them separately. So here we have the plots for the amounts, and we see that there is a little correlation, but not too high, and this happens for all the years. And then we have the amounts, and the amounts have special patterns, so we have isolated dots, and it makes sense because when you have the number of transactions that you can have, so it is 1, 2, 3, 4, but you cannot have the numbers in between, so you cannot have 2.5 transactions. So that is why the data is distributed in this regular pattern. And we can compute the correlation matrix. So we see that the correlations between the amount of spent within the years, they are weak, and these weak correlations is consistent with these plots where there is some correlation between the two. We can draw a line, but the data separate quite a lot from this line, so that is consistent with these low correlations in this group. So these are the correlations of the amounts and the amounts Okay, so this is the amount block. This is the number of transactions block, and we see that the correlation is even worse. Actually, the correlation is the Pearson correlation is not well defined for, or it was not meant for this kind of data. You can compute it, but for instance, things like p-values and confidence intervals and these kind of things that you cannot construct if you are violating the assumption of the data being Gaussian. And then this block here is the block of the correlation between amount and number of transactions. And again, we see that there is some correlation. It is significantly better than this one, but still those are weak correlations. Okay, so now we will do two clusterings. So the first clustering is on the variables, while the second one is on the data itself, so on the observations. So if we look at the data, this one here, what we have is 4,000 of these rows, so each row is an individual, and then in columns we have the different variables. So we may cluster the variables and trying to look which variables are similar to other variables, and that is a clustering by columns, while we may also do a clustering by rows. So a clustering by rows is which observations are similar to each other, while the clustering by columns is which variables are similar to each other. So we go down to here. So as usual, we normalize the data, so we normalize it to be between 0 and 1, and then we are linking with a complete hierarchical clustering. So this is the hierarchical clustering, and we are using complete, using the distance given by the correlation between variables. So and this is the clustering. So we see that the transactions in 2014 is correlated, or it is close to the variable of the amount of transactions in 2014, and the same for all other years. So there is no surprise in here, and if anything, we can say that 2013 and 2014 are a little bit closer, and these 3 years that are the ones in the middle, are a little bit more similar to each other, and 2011 and 2015 they're more dissimilar. This accounts for the fact that these 3 years are complete, while these 2 years are incomplete. Okay, so now we can do the clustering of observations. We will take only the variables that are related to the amount, and here we are giving new names to those variables, and then we are making a clustering with different number of clusters going from 1 to 20. So here is the curve of the evolution of the distance between the points and the centroids, and it is negative because remind that in scikit-learn the score is the opposite of this distance. So but we see that the expected pattern, so as the number of clusters grow, this distance, or this negative distance, diminishes and goes towards 0. So we will choose, there is no clear cutoff here in the number of clusters, so we will choose 6 as a relatively a compromise between having few clusters. If you have many clusters, they are more and more difficult to interpret and not overfitting the data. Okay, so we will use 6 clusters, and these are the different clusters. So we see that the data is normalized between 0 and 1. So we see that there are a group of people that this is 2005, missed, yeah, 2015 is not there. The last value in the range is not taken, so has been done with only 2011 to 2014. So I wanted to see, yeah, this one. So that means that in 2011, these people here in this cluster, they were at the 27th, not percentile, because these are not percentiles, but in the range from 0 to 1, they were in the lower quarter, and also in 2012, 13, and then in 2014, for some reason, they move up uh, to the upper quarter, or to the upper half. And these people were the opposite, so they were in the lower quarters before, but then in 2013 they moved to the middle, and then they came back. And then these other people, it was the opposite, so they started being in the upper half, but then they moved down to the lower quarters. So we can make a graphical representation of that. So we have 5 or 6 different clusters. So we have a cluster that is more or less regular, that they don't change their purchasing pattern over years. We have some other group that was, for instance, this one, that started, this was the first cluster we were analyzing. So they started in the lower quarter, and then they moved up in the last year to the upper half. And we had, well, the second one that was the opposite, or not the opposite, but the maximum was reached in 2013. We have some of the group that the maximum was in 2012, and some other group in 2011. And then there is so we have 5 clusters, or 4 clusters in which the maximum is attained at each one of the years. And then we have some other group that is this one that made an increase in the last year, but not as high as the first group. And now, once you have segmented your customers, you can try to address them with different strategies. And this is very much used in marketing. And this would be all for this practice. So see you in the next one.